In this chapter, we're going to be going over equivalent statements. So essentially, we're going to be using everything that we've done so far to do this section. So starting with the definition of an equivalent statement, two statements are going to be called equivalent, and we're going to symbolize it with this double-headed arrow. So it's different from the biconditional because it looks like an equal sign with two arrows on it. So two statements are equivalent if they have exactly the same truth values in their answer columns of the truth tables. Okay, so let's go ahead and start with an example here. So we have two statements. We're going to determine if they're equivalent. We have the conjunction P and Q or R, and then we have the other disjunction P and Q or P and R. So let's go ahead and set up this truth table with three cases, or three statements. It's going to give us 8 cases as usual. Okay, so we have our typical 8 cases here for using 3 statements. And what I'm going to do is I'm actually going to create both of these answer columns on the same truth table here. So let's take a look at what we need now. We don't have any negations, so let's go ahead and just do this one first, the one on the left. So we have to do the disjunction Q or R. So for the disjunction Q or R, that's going to be true when either Q is true or R is true. So taking a look at that, first one's going to be true, 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 false because they're both false, and then true, 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 and then false because they are both false. Okay, so let's just go ahead actually and just complete this whole entire first statement. So let's do the answer column for it, which is the conjunction P and Q or R. So let's take a look, make sure we're looking at the correct columns. We're looking at this one and statement P. So this is only going to be true when they are both true. They're both true in the first case, they're true in the second case, they're true in the third case. One of them is false, and one of them, at least one of them, will be false for the remaining ones. So we get true, 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 and then the rest are false. Okay, so that's already one answer column. So I'm just going to put a little arrow to it. And now let's do the other statement on the right. So we're going to need to do a couple things for that one as well. Let's start with the conjunction P and Q. So we have P and Q. So we're looking at statement P, statement Q. This is only going to be true when they're both true, which is the case for case 1 and 2. And then after that, it's going to all be false because both of them are not true. Okay, and now let's take a look at the next set of parentheses before we finish it up. We have the conjunction P and R. So taking a look at statement P and statement R, truth values, it's a conjunction, so once again, it's only going to be true when they are both true. Case 1, they're both true. Case 3, they're both true. Other than that, they're going to be false everywhere else. So that's going to be that column. And now we just need the last answer column for it, which is the whole entire disjunction. So let's go ahead and write that. So we have P and Q or P and R. So we're looking at the two columns that we just created. We're looking at this one and we're looking at this one. Since it's a disjunction, it's going to be true if at least one of them is true. So we have true, true, true. And now for the remaining cases, they're going to be false because they're both false. So we have false, 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 false. Okay, so that is the answer column for this one right here. So taking a look at these and comparing them, comparing their truth values, these do have the same exact truth values, so that means these are equivalent statements. Okay, so we can write it using the correct notation like I did at the bottom of the screen here. Okay, so let's go ahead and do another one. We're going to determine if these following statements are equivalent. So we have two statements. If the sky is clear and it is after sundown, then we can see Saturn. And the next one is if the sky is not clear or it is not after sundown, then we cannot see Saturn. So first we have to convert it into symbolic notation. We have three different statements here, so we're going to have P, Q, and R. Let's let statement P be the sky is clear. Statement Q is going to be it is after sundown. And statement R is we can see Saturn. Okay, so let's convert the statements into symbolic form. So the first one, I always see the comma first. We have the two statements before it, so they're going to be in parentheses. So we have it's going to be a conditional after the parentheses because we have an if and then we have a then. So inside the parentheses, the sky is clear and it is after sundown. That's going to be P and Q. And then it's the conditional after the parentheses. Then we can see Saturn, so that's going to be R. Okay, so that's the first one that we're going to be doing. And the second one, we have the comma right here. Once again, we have the parentheses covering the first two. If the sky is not clear, so that's going to be not P. Then we have or, so it's a disjunction. It is not after sundown, so that's not Q, negation. Then we cannot see Saturn. Is going to be another conditional, and it is also a negation. Okay, so we have three cases here, so let's go ahead and set it up. Or three statements, again, three statements, so 8 cases. Okay, so we have our typical 8 cases for 3 statements, and it looks like we're going to need a negation column for all of them. So we're going to have not P, we are going to have not Q, we're going to have not R. So I'm going to actually just pause it real quick and fill it in because we should be comfortable filling these in by now. So here are these negation columns. So now let's take a look and I'm going to do the first statement here. Let's finish this one off. So let's do the conjunction P and Q first. So it's going to be P and Q for the next one. And it's a conjunction, so this is only going to be true when both P and Q are true. They're both true in case 1 and 2, and then it's going to be false everywhere else. And next, for the next column, let's just finish up. Let's finish up the first statement. So now we have to do the conditional with R. So it's going to be if P and Q, then R. And let's take a look at the correct columns. We're starting with the one that we just did, and then R is going to be the consequent. So P and Q is the antecedent, and R is the consequent. So it's a conditional, so it's only going to be false if it goes from true to false. So the second case, it goes from true to false. So that's going to be, that's going to be false. And that looks like that's the only time it goes from true to false. So all of the other ones are going to be true. Okay, so now let's do it for the second statement for that conditional. So we only have 2 more things to do. We have 2 more columns. So we have to do the parentheses first, not P or not Q. And then the last column is going to be the answer column for that one. So we're looking at the negations, not P, not Q. We're doing a disjunction for it. So that for this one, it's going to be true when at least one of them is true. That's going to be statement or case 3, case 4, 5, 6, 7, 8. So they're only both false in case 1 and 2, so those are both going to be false. And now for the last thing, for the answer column for it, we have if not P or not Q, then not R. So we are looking at the column we just created, and we're looking at the negation for R. Okay, so conditional, it's going to be false when it goes from true to false. So once again, we're going from the column on the right is the antecedent, the column on the left is the consequent. So it's only going to be false when it goes from true to false. So it goes from true to false in case 3, and case 5, and case 7, it looks like. Oh, sorry, those should all be falses. So it went from true to false, so false, true to false, false, true to false, false, and then everything else is going to be true. Okay, so now we take a look at our 2 columns in question. That was going to be this one right here, and this one right here. And we have to see if they are identical. So obviously these are not identical because the second case, there are already different truth values. So these are not equivalent statements. Okay, so oops, I should say not, so these are not equivalent statements. Okay, so for the next thing here, we have, we're going to determine which, if any, of the following statements are equivalent to it is not true that the tire is both out of balance and flat. So we have 4 options here, so let's come up with our statements in symbolic form first. So we only have 2 statements, so this one won't really be that bad. So statement P is going to be the tire is out of balance. And statement Q is going to be the tire is flat. Okay, so we only have 2 statements, so it's going to be 4 cases total. So the original statement is it is not true. So what that means, that's the equivalent of saying it is false. So that's going to be the negation sign and then parentheses. And then we have a conjunction. It is out of balance and flat. So that's going to be it is false that P and Q. Okay, so what we're going to do is come up with a truth table, and that's going to be one of our columns. Let's figure out what these other statements are going to be in symbolic form as well. The first one for A is if the tire is not flat, then the tire is not out of balance. So that's going to be a conditional, not Q, so it's starting with Q. Not Q, if not Q, then not P. So both of them were negated, and we just started with Q, and it was a conditional. Okay, and then for B, the tire is not out of balance, or the tire is not flat. So it's a disjunction with negation, so it's going to be not P or not Q. And for C, the tire is not flat and the tire is not out of balance. That's going to be not Q and not P. It's conjunction with and they're both negated, and it was starting with Q. And then the last one for D, it is a conditional. It is if not P, then not Q. So if not P, then not Q. Okay, so we have to come up with a truth table for all of these, which isn't as bad as it looks. So I'm going to start by just filling in what we usually fill in. So we have our 4 cases with P and Q, and I'm just going to fill in the negations right now also. Okay, and now let's fill in the original one. So let's do the one up here. It is false that P and Q. So first we need P and Q. So P and Q is going to be the conjunction. This is only going to be true when they're both true. They're both true in case 1. Other than that, they're going to be both false. It's going to result in a false truth value. And now we're just going to need the negation for that. So all we have to do is negate that column. So instead of true, false, 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 we get false, true, true, true. Okay, so I just had to move that over to create some room here. So now let's go ahead and do the rest of these. So let's take a look at A. So in A, it is if not Q, then not P. So that's going to be the next one. So if not Q, then not P. And that's going to be starting with not Q and then going to not P. So this is going to be false when it goes from true to false. That's going to be case 2. It goes from true to false. The rest of them are going to be true then. Now let's look at B. B is not P or not Q. So that's going to be not P or not Q. So taking a look at that, that's going to be, once again, these two columns right here, not P and not Q. Since it's a disjunction, it's going to be true when at least one of them is true. So that's going to be false, true, true, true. Next, let's take a look at C. C was not Q and not P. So this is the conjunction. So the conjunction is going to be, let me write it down here, not Q and not P. This is going to be true when they're both true. They're both true in case 4. So that means they're going to be false everywhere else. Okay, and then for the last one, for choice D is a conditional which says if not P, then not Q. So if not P, then not Q. So now we're doing the same thing from part A, except in the reverse direction. So it's only going to be false when it goes from true to false, and that is going to be case 3. Case 3, it goes from true to false, so everywhere else is going to be true. Okay, so now, let me label what each one was. So this was the one that we were comparing everything to. This was choice A. This was choice B. This was choice C. This was choice D. So we can see that choice B is going to be the same truth values in the answer column as the original statement. False, true, true, true. So that statement is going to be equivalent. So if we go back up here, that means the statement, it is not true that the tire is both out of balance and flat, is equivalent to the statement the tire is not out of balance or the tire is not flat. So those would be equivalent statements. So the next thing is going to be De Morgan's laws for logic. So if you remember De Morgan's laws with sets, it's essentially the same exact laws. So we have our two laws. The first one is it is false that P and Q. That's going to be equivalent to not P or not Q. And statement 2 is it is false that P or Q. That's going to be equivalent to not P and not Q. So essentially the negation is the same as the complement, the conjunction is the same as the intersection, and the disjunction is the same as the union. And an individual statement is going to be equivalent to an individual set. Okay, so those statements are equivalent, so let's use that shortcut kind of, so we don't have to do a truth table now, to come up with the answers for this next question. So select the statement that is logically equivalent to I do not have investments, but I do not have debts. So first, let's just say which statements are going to be our P and Q. So let's let statement P be I have investments and statement Q be I have debts. So that means the original, so remember too that since these had negations in them, they're not part of the actual statements. So this statement that we have here is going to be a conjunction because of the word but, so it's the same as and. It's going to be not P and not Q. Okay, so before we even take a look at it, at these examples here, let's look up here at De Morgan's laws. De Morgan's law 2, that statement is right there. So what we're going to be doing is seeing which statement gives us it is false that P or Q, and then those are going to be equivalent. Okay, so let's go ahead and put these statements A, B, C, D in symbolic form. So statement A is I do not have investments or I do not have debts. So that's going to be not P or not Q. And then statement B is it is false that I have investments and I have debts. So that's going to be it is false that, so negation, parenthesis, and then conjunction, P and Q. Statement C here is going to be it is false that I have investments or I have debts. So it is false that statement P or statement Q, disjunction. And last one, I have investments or I have debts. That's just going to be P or Q with the disjunction. Okay, so now using De Morgan's law, it is hopefully pretty obvious. Once again, De Morgan's law number 2 here. It's pretty obvious that statement C is going to be equivalent. So let's rewrite that down here. So we can say that these two statements are equivalent by De Morgan's law. Okay, so it's a nice shortcut where we don't have to actually create the truth table. So let's use, for this example, use De Morgan's law to write a statement that is logically equivalent to it is not true that tomatoes are poisonous or eating peppers cures the common cold. So once again, let's start off with determining which statement's going to be P and what's going to be Q. So statement P is going to be tomatoes are poisonous. Statement Q, eating peppers cures the common cold. So that means this statement from the question here, written in symbolic form, is going to be it is not true that, so that's the same as it is false that. So negation, parentheses, tomatoes are poisonous, statement P. It's a disjunction with or, so P or Q. Okay, so by De Morgan's law, we know that the statement it is false that P or Q is equivalent to the statement not P and not Q. So we just need to rewrite this one in words. So not P and not Q is going to be tomatoes are not poisonous and eating peppers cannot cure the common cold. Okay, so that would be our equivalent statement without having to create a truth table again. Okay, let's do one more of these ones. Let's use De Morgan's laws to create a statement equivalent to we cannot go to the fireworks, but we can go to the ice cream shop. So let's determine what's going to be P and what's going to be Q. So let's have statement P be we can go to the fireworks, and Q is we can go to the ice cream shop. Once again, ignoring the negations. So this is going to be a conjunction. Let me just move this down a little bit. So it's going to be the disjunction, not P, or sorry, the conjunction, not P and Q. Okay, so let's take a look up at De Morgan's laws. This is not P and Q, but when we're looking at De Morgan's laws, neither of these on the right says not P and Q. The closest thing is going to be this one right here, where it says not P and not Q. So let's go ahead and just write this down and then we'll go from there. Okay, so when we look at what we have not P and Q. This one is not P and not Q. So the Q is negated here. So what we actually have to do is we're going to use the same law, except use the opposite truth value for Q. Okay, so all I did here was I rewrote this statement. I rewrote De Morgan's law, except I negated the Q. So instead of Q here, it became not Q here. Instead of not Q here, it became Q here. So you are always allowed to do that when you are working with statements like this. Okay, so now this is the same as this right here. So all we have to do is rewrite this portion in words, and that's going to be our equivalent statement. So that's going to be the statement, it is false that we can go to the fireworks, or we cannot go to the ice cream shop. Okay, so that is De Morgan's law. So for the next thing, we have conditional statements as disjunctions. So this is going to be a way to see equivalent statements between a conditional statement and a disjunction. So for example, if we have the statement if P then Q, that is actually equivalent to the statement not P or Q. So if you really wanted to, and I recommend doing this, you could create a truth table for both of these and see that these are equivalent statements. Okay, so let's go ahead and use this shortcut to do this example. So let's write a conditional statement that's logically equivalent to the cows are in the pasture or the horses are not in the barn. Okay, so we have statement P, statement Q. Statement P is going to be the cows are in the pasture. Statement Q is going to be the horses are in the barn, ignoring the negation. So this statement from the example is going to be in symbolic form. It's going to be P, and then a disjunction, P or not Q. Okay, so let's go ahead and rewrite this statement up here. So we have the equivalent statement, if P then Q, if and only if not P or Q. Okay, so we have to recognize that this is different than this one right here. So this is going to be actually the same thing as if we have to negate P. So we have plain P, and then we have the negation of P, and then we have the negation of Q and plain Q. So we have to negate both of them to use this form. So this is going to be the same as if not P, then not Q. That is going to be equivalent to P or not Q. So now our statement is equivalent to this one right here. So now we can just use this one on the right and reword this as a conditional. So that's going to be if not P, then not Q. So using our statements P and Q here, we have if the cows are not in the pasture, then the horses are not in the barn. Okay, so this is essentially just relating a conditional to a disjunction. Okay, and the next thing we're going to be doing is the negation of a conditional statement. So we can negate a conditional statement using the fact, what we just did, that if P then Q is equivalent to not P or Q. So we're going to negate that, and then we're going to use De Morgan's laws. So let's start by determining an equivalent statement for this right here. So we're going to start with what we just wrote down. So we're going to start with if P then Q, if and only if, or not if and only if, is equivalent to. So if P then Q, that's equivalent to not P or Q. So we need to negate the left-hand side. So let's negate that whole thing on the left. So if we negate that side, that's going to be the same as if we negate the right side. Okay, so all I did so far was just rewrite our equivalency that we had at the top, and then I negated both sides. And we already have what we want here on the left. We have the negation for the conditional, that's going to be equivalent to, now we're going to apply De Morgan's law to the right-hand side. And from De Morgan's law, we have to adjust a little bit by negating the statement P. We just have to use De Morgan's law and then negate statement P, and then we get this. So instead of this right here, we're going to use this version on the right and say that the negation of the conditional is equivalent to P and not Q. Okay, so that is why these are equivalent. So now we can just know that the negation of the conditional statement written as a conjunction is going to be, it is false that if P then Q is equivalent to P and not Q. Okay, so in the previous one we had a conditional as a disjunction. Now we have the negation of a conditional written as a conjunction. Okay, so let's do this example. Let's write an equivalent statement to it is false that if you hang the picture, then it will be crooked. So as usual, let's start off with our statements P, statements Q. Statement P is you hang the picture. Statement Q is the picture will be crooked. So the statement, the compound statement in the example, it is false that, so the negation parentheses, that if you hang the picture, then it'll be crooked. So that's going to be if P, then Q. Okay, so now we can use that equivalence right at the top of the page here and say that this, the negation of if P then Q, is equivalent to P and not Q. So an equivalent statement is going to be this portion right here, P and not Q. So we're just going to read that off in words. That's going to be you hang the picture and the picture will not be crooked. Okay, so that is an equivalent conjunction given a negation of a conditional. Okay, so let's do one more topic here, and that's going to be variations of the conditional statement. And these variations that we're going to be looking at here are going to be made by either switching and or negating the antecedent and the consequent of the conditional statement. So the variations are going to be the converse, the inverse, and the contrapositive. So they are summed up right here in this little table. So first we have the conditional. We know the conditional already. We have if P then Q. The converse of the conditional is going to be them switched. So instead of if P then Q, the converse is going to be if Q then P. Okay, and then for the inverse is going to be both of them negated. If not P, then not Q. And then the contrapositive is going to be switched and negated. If not Q, then not P. So the converse is Q and P being switched. The inverse is negated. Contrapositive, switched, and negated. Okay, so let's determine by creating a truth table which variations are going to be equivalent to each other. Okay, so let's set this up. We're going to have two statements, so 4 cases with P and Q. So we have the usual setup here with P and Q, and let's take care of the negations because we're going to need those in a second. So let's do not P, and then let's do not Q. And I just filled those in really quickly because once again, hopefully we're comfortable with it. And let's go ahead now and fill in all of these variations. Okay, so first let's just do the conditional. So we have if P, then Q. So for the conditional, this is only going to be false when it goes from true to false. And that's going to be one time here with these two statements. so the rest are going to be true. Next, let's do the converse of the conditional, which is going to be both of them switched. So that's going to be if Q, then P. So this is the converse. And same idea, it's going to be only false when it goes from true to false, and that's only going to be in statement or case 3. The rest are going to be true. Next, for the inverse is when they're negated. So if not P, then not Q. And that is the inverse. So let's take a look at those columns. So not P to not Q. Once again, same rules here. It's going to be false when it goes from true to a false, which is going to be statement or case 3. So all of the other ones are true. And lastly, for the contrapositive, switched and negated, not Q to not P. So if not Q, then not P. And this is the contrapositive. So we're looking at the negations again. And this time starting with not Q and going to not P. The only time this is going to be false is when we have case 2. It goes from true to false. All of the other ones are true. Okay, so taking a look at which ones are equivalent here, it looks like the conditional is equivalent to the contrapositive, and the converse is equivalent to the inverse. Okay, so I just kind of summed that up here at the bottom of this page. We have the conditional is equivalent to the contrapositive, and the converse is equivalent to the inverse because they have the same truth values. Okay, so let's go ahead and do one more page here. Let's see this example. For the conditional statement, if the painting is by Andy Warhol, then the painting is valuable. And that's the conditional, and let's write the converse, inverse, and contrapositive. So first, we have statement P is going to be the painting is by Andy Warhol, and statement Q is the painting is valuable. So we're obviously given the conditional in the original one, which we're told that. So let's take a look at the converse first. So the converse statement is going to be when they are switched. So it's going to be if Q, then P. And we would read that as if the painting is valuable, then the painting is by Andy Warhol. So for the next one, let's take a look at the inverse. The inverse is when we negate them. So that's going to be not P, or if not P, then not Q. And we read that one as if the painting is not by Andy Warhol, then the painting is not valuable. And for the last one here with the contrapositive is going to be switched and negated. So that's going to be if not Q, then not P. And we read that one as if the painting is not valuable, then the painting is not by Andy Warhol. Okay, so I recommend taking a look at the conditional statement, reading that, and then reading the contrapositive, knowing that those are equivalent, and then the converse and the inverse are equivalent, so go ahead and read those and see how those mean the same thing. Okay, let's do one more example here. Let's use the contrapositive to write a statement logically equivalent to if you don't eat your meat, then you can't have any pudding. So let's write statement P and statement Q. Statement P is you do eat your meat, and statement Q is you can have any pudding. So ignoring the negations. So in the example, this would be written as if not P, then not Q. So we know based on what we just said that the conditional if P then Q, that's equivalent to the contrapositive if not Q then P. So all this is the reverse order for this particular example. So it's going to be the same thing. So instead of, from our original setup was right here, if not P then not Q. So what we're going to do is we're going to write it as if Q then P. So we're going to read this off as if you can have any pudding, then you do eat your meat. So that is an equivalent statement to the statement from the example. Okay, so that is it for this section.